Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm gonna jump back on to close this out, and I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday Night Math Night. I'm so excited that you're joining us tonight. Like Dr. A said, I've got about 10 problems that we're going to go over. And some of these problems do come from other people who have watched and they've said, hey, you know what? I really need you to go over geometry problems, or I really need circle problems, or whatever. So when you're watching, think about what you want me to go over in the upcoming weeks, and I am more than happy to add that to my slides. It makes it more fun for me. It makes it more beneficial for you, so it's a win-win. That said, some of the problems we are going to be going over tonight are from some special requests. I did see one special request on our Facebook page. Unfortunately, I was not able to get that into this week's, but I will definitely get that matrix problem in for next week if you are watching, Gary. So I will make sure that we go over that next week. Before we get started, let me know in the comments where you're from, what test you're prepping for, and what your favorite soda is. I only ask that because for Teacher Appreciation Week at our school, I'm a coach, and we're giving our teachers these silly little inflatables with their favorite drink. So what's your favorite drink? My favorite drink is either Polar Water or Dr. Pepper. So where are you from? What test are you prepping for? And what's your favorite drink? So I don't know, let's just get started. My brain is not working today. So problem number one is a geometry problem. Let me go ahead and switch this screen over. So a triangle is inscribed inside of a square. What is the area of the shaded region? So there are two different ways that we can solve this problem. This problem is definitely going to be probably more of a middle school Praxis core GK math kind of problem. However, everybody needs to understand properties of circle or properties of squares, properties of triangles, and how to find area of a shape. So this really is beneficial for everybody. So a triangle is inscribed inside of a square. What is the area of the shaded region? Again, two different ways that we can solve this problem. Looking at this square, we can find the area of the square and then subtract out the area of this white triangle. Or we actually have enough information for us to be able to just find the area of each of these triangles and then add them together. So I'm going to go ahead and do it that way. I will quickly go over the other way too, because I like to show you guys multiple ways to solve one problem. So because we know this is a square, we know that all the sides are the same. So that side is 12 and this side is 12 and this side is 12 and this side is 12. We know that the area of a square equals length times width. So I can just multiply 12 times 12. So 12 times 12 equals 144. Remember, that's the area of our square, not the area of the shaded region. So now for us to find the area of that shaded region, I need to subtract out the area of this triangle. What is the area of a triangle? Well, we know the area of a triangle equals 1/2 base times height. The base is identified for us as 12. So 1/2 times 12. And what's the height of this triangle? The height of this triangle is also 12. Remember, height of a triangle is the perpendicular connector to the base. So for a right triangle, the height is one of the legs. But for a non-right triangle, the height has to be dropped perpendicular to the base. So the height is also 12. 12 times 12, pull out my handy dandy calculator. I know it's 144. But 144 divided by 2 equals 72. So the answer is C. Now, let's talk about how we can find the area of this shape a different way. We can just find the area of those right triangles. So area equals 1/2 base times height. Area equals 1/2 base. I'm going to skip. Height is 12. Height is 12. The base, what is the base going to be? The base is going to be 6. How do I know that? Because the entire length is 12. And what did they tell us? They told us that this section and this section are equal. That's what those congruency tick marks mean. So if each of them is equal, 12 divided by 2 is 6. 1/2 times 6 is 3 times 12 is 36. 36 plus 36, because 36 is the area of one triangle. And then I'm going to do another triangle, equals 72. So 2 different ways to solve this problem. They both work. I apologize in advance if you can hear crying. I don't know if you can hear the crying. I can hear the crying. He's in the back of the house with my mom, and he's totally fine. But I apologize in advance if you can hear it. All right, I'm going to say some shout outs. Hi, Gary. Hi, Tabitha. Hi, Caroline. Hi, Hannah, I think. We've got a couple people from Texas and Florida. I love it. Diet Coke, cream soda, Sprite, and cherry vanilla Coke. I do love myself a good cherry drink. Cherry Coke, cherry Dr. Pepper, cherry anything really, but I don't like cherries, which is pretty funny. Or cherry tasting medicine. That's gross. All right, problem number 2. A pool company is building a rectangular pool with a deck that measures 6 feet all the way around. The pool will measure 14 feet long by 18 feet wide. If the deck costs $3 per square foot, how much will the deck cost? Multi-step word problem here. So we've got a pool, we've got a deck, we've got a cost. So we need to find the area of the deck And then we're going to have to multiply that by $3 to find the cost of that deck. But finding the area of that deck is going to be multi-step too. Let's draw a picture. Drawing a picture is always a good idea when you have a geometry problem. So we've got a pool with some water. And I always like to draw a little bit inside of it, not because I want to waste time, but just so I know what I'm drawing. That's my pool. And the pool is 14 feet by 18 feet. So this is going to be 14 times 18. And I'm going to use my calculator. If you are taking the GK, you definitely get a calculator. Everybody else, check your blueprint, your study guide, your study companion, and you'll be able to see if you get a calculator or not. Equals 252 feet squared. That's the area of my pool. Then we have an area of a deck. We've got a deck surrounding this pool that measures 6 feet all the way around. There's my deck. Let's think about this. The most common mistake I see is that either people do 6 times 6 equals 36 for the deck, or they realize they need to add the 6, but they don't add it enough times. Watch. This is going to be 6. This is going to be 6. This is going to be 6 feet wide. And this is going to be 6 feet wide. That said, we need to figure out the entire length. So I need to know what this whole length is. Well, if we think about it, from here to here is the length of the pool. We'll call that 18. And we'll call this 14. Well, how much is this section right here? 6. How much is this section right here? Also 6. So to find the entire length of that, I have to do 18 plus 6 on this side, plus 6 on this side. And the most common mistake I see is that people do 18 plus 6 and that's it. So 18 plus 6 plus 6 is going to be 30. So the whole length of that side is 30. I'm going to do the other side just the same. So I know that this length is 14. And then I know that this is 6 and this is 6. So I have to do 14 plus 6 plus 6, which equals 26. What am I going to do now? Now I'm going to find the entire area of this entire thing. But I'm not going to put a deck on top of my pool. So I'm going to find the area of the whole shape, and then I'm going to subtract out that pool. So I'm going to find the area of the entire shape minus the pool. So I'm going to do 30 times 26, and 30 times 26 is 780. And I'm going to subtract out that 252 that we already solved for. So 780 minus 252 equals 528. What does that number represent? That number represents the area of just the deck. That number represents the area of just the deck. But we're still not done, because the question asked us, if the deck costs $3 per square foot, how much does that deck cost? How much is that doggy in the window? I don't know why I thought of that song. So I'm going to do 528 times 3, which equals $1,584, which is C. As I'm solving these problems, if you have any questions at all, please don't hesitate to ask. I'm more than happy to go back, answer any questions that you have. That's why we're here. We're here not for me to present at you, but for us to work together on these problems and for you to learn through the process. So if you have any questions, just let me know. Hey, Joan, how are you? Water's your best friend. Water needs to be my best friend. I don't drink soda or water, really. I just don't drink anything. But water definitely needs to be my best friend. All right, problem number 3. In a school, the ratio of boys to girls is 4 to 5. If there are 672 total kids in the school, how many boys attend the school? All right, so ratio problems are interesting because we have to set up equivalency. So if I'm going to set up 2 ratios that are equivalent, I have to have the same pieces. So this is boys to girls, but then they gave us a total. So a lot of times I see people go boys over girls equals boys over girls, but they'll do this. 4 over 5 equals X over 672. But when we look at that ratio says boys over girls equals, and they know that they have to have an X because it asks for how many boys, but there are not 672 girls in the school. There are 672 total. So this ratio does not equal this ratio, which is going to give you the incorrect answer. So how do we solve that if we don't know how many girls are in the school? Simple. We're going to do boys to total equals boys to total. We're going to take what we need and what we've been given and use that for our ratio. I'm going to say that again because that's critical that you understand that. We're going to take the piece that we need and the part we've been given and make that my ratio, boys to total. Yes, we've been given this information and we're going to use it, but that's not the most critical information. So now my smaller ratio or the original ratio is boys to total. How many boys are there? 4. How many total kids are included in this ratio right here? 4 plus 5 equals 9. That's my total in that little pocket of the school. Equals boys is what I'm looking for. Total is 672. Now I can cross multiply and solve. So I'm going to cross multiply. 4 times 672 equals 9 times B. Again, I'm going to use my calculator just so that I don't make a mistake. 672 times 4, 2,688 equals 9B. Divide both sides by 9. And B equals 298.667 repeating. So we're going to round up, and that gives us 299 because we can't have 0.6 of a child. Does that make sense? All right, let's keep going. Like I said, if you have any questions at all, please don't hesitate to ask. As a part of a survey, 1,200 people were asked to name their favorite sport, where the table and circle graph below present the results. Find the central angle for the portion of the circle graph representing soccer and hockey combined. Find the central angle percentage for the portion of the circle graph representing soccer and hockey combined. So if I'm trying to find the central angle, I know that I'm trying to find the actual degree measurement of that angle. So they gave us an example here for X degrees in the football section, but we're not trying to solve the football section. And that's a trick right there. We're trying to find the soccer and hockey combined section. So if we look at soccer and hockey, we've got soccer here, and we've got hockey here. So we need to add those two values together, find the percentage, and find what percent of the circle that is. Complicated problem. So how many total people are there? Well, they did part of the work for us. They said there are 1,200 people. Well, if they didn't tell us the total, we would have to sit and add all of these numbers up to find the total. So I'm not going to sit here and do it. I'm going to trust that they added their numbers together and got 1,200 appropriately. In order for me to find a percent of, I'm going to do my part over my total or my whole. So that said, what part am I looking for? I'm looking for my soccer and my hockey combined. So soccer is 396 and hockey is 84. So I'm going to add 396 plus 84 and put that over my total of 1,200 people. Following? All right, let's add those together and see what we get. 396 plus 84 equals 480 over 1,200. If I divide that in my calculator, I get 0.4. What in the world does that even mean? That is the percentage of the circle or of the people that we're looking at. Remember, we can convert percents to decimals to fractions to ratios and convert anywhere in between that. So I have a decimal here, and in order to convert a decimal into a percent, and again, I'm going deep in the weeds with this, not because the people who need this problem need it, but because other people might need it. So this problem is definitely a high school problem because we're looking for central angle. We're looking at a 6 through 12 or 7 through 12 math test. However, my elementary people, you guys need to know how to convert percents to decimals to ratios and all of that. So that's why I'm going deep in the weeds, because I want everybody to get something out of every problem. So to convert this percent into a decimal, remember, we're going to hop that decimal 2 places to the right. So 1, 2, add a 0. This is 40%. So 40% of the people like soccer or hockey. Now, what are we going to do with that information? Now, if I'm going to find the percent of the circle, we know that there are 360 degrees in a circle. So if I want to know how many degrees are being taken up by the soccer and the hockey, I can multiply 360 times 40% to find what that angle is going to be. So 360 times 0.4 equals 144 degrees. All right. Did that make sense? Hi, Terry from Middleburg, Florida. I do not know where Middleburg is. Where's Middleburg? All right. Problem number 5. This has a star to show me that somebody asked for us to go over linear equations last week, specifically perpendicular and parallel, I believe. So that's why there's a star next to this problem. What is the equation of the line in standard form that is perpendicular to 2x minus 4y equals 20 and has the same y-intercept? Awesome, near Jacksonville. What is the equation of the line in standard form that is perpendicular to 2x minus 4y equals 20 and has the same y-intercept? We've got 3 key pieces of information in this problem. It has to be in standard form. it needs to be perpendicular to this line, and they need the same y-intercept. Let's talk about equations of lines. The equation of a line is y equals mx plus b, or ax plus by equals c, or y minus y1 equals m times x minus x1. I mean, could they come up with any other different ways to write the equation of a line? This one right here is slope. Don't want to use that color. This one right here is slope-intercept form. This one right here is standard form. And this one right here is point slope form. So the first thing I notice is that it needs to be in standard form, which means A and B are already out. These are in slope-intercept form, not standard form. So I'm going to eliminate answer choices that I know might trick me later on. Those are not in standard form. Now, my next piece of information is that it has to be perpendicular to this line. What is the relationship between two lines that are perpendicular? Well, their slopes are negative reciprocals. What did I just do? Reciprocals. That means if the slope of line A is A over B, then the slope of the line perpendicular to that is going to be negative B over A. That said, how do I find the slope of this line? I have to put it into slope-intercept form or point slope form. So I need to isolate that y value so that I can see what the slope and the y-intercept are. So let's go ahead and take this equation, 2x minus 4y equals 20, and let's isolate that y. So I'm going to subtract 2x from both sides. I have negative 4y equals negative 2x plus 20. Why did I not get 18x? Because I cannot subtract things that are not like terms. I can't do 20 minus 2x. And why did I put the 2x in front? Because the x is in front in y equals mx plus b form. And so I want to keep that consistent. Now I'm going to divide both sides by negative 4, but that means I'm going to divide everything by negative 4, not just the first thing I see. So I get y equals negative 2 divided by negative 4 is positive 1/2. 20 divided by negative 4 is negative 5, because a negative divided by a negative is a positive. So now I actually have some useful information. They have to have the same y-intercept. So I know my y-intercept is going to be negative 5. They are perpendicular. So I know my slope of my new line, my y-intercept is going to be negative 5, and my slope is going to be negative 2. Why? Because I'm going to take this, I'm going to flip it upside down, and I'm going to make it negative. So 1/2 flipped over is 2 over 1 and negative. Now I'm going to use this information to put it into y equals mx plus b form and then manipulate it back to standard form. So y equals mx plus b. So I'm just going to make that a -5 for consistency purposes. And now I'm going to move that negative 2x over, plus 2x. So I get 2x plus y equals negative 5, which means C is my answer. We're halfway through the time. We're halfway through our problems. We are making great progress. All right. What is the x coordinate of the point on the line drawn when y equals 12? This is confusing. What is the x coordinate of the point on the line drawn when y equals 12? So looking at this line, there's a couple different things we can do. We can look for the pattern here and then use that pattern in a table of values to figure out what we're looking at. Or we can figure out the equation of this line and then plug in what we know. That's my favorite way to do it. So I know that the equation of my line, actually I'm going to solve this up here, is y equals mx plus b. And my b is my y-intercept. So the y-intercept, oh, there's a bug. The y-intercept is positive 2. So I have y equals mx plus 2. The slope of the line, which is m, I can solve or I can count. The slope is y minus y over x minus x. That said, if I do y minus y divided by x minus x, I can use this point 0, 2 and this point 3, 3 as my slope. So my y value is 3 and 2. So 3 minus 2 divided by 3 minus 0, which equals 1 over 3. So I'm going to erase my m and replace it with 1 over 3. That said, I could also have counted that. So I could have seen that I'm rising 1 and running 1, 2, 3. Why did I not count all the little boxes? Because those aren't the actual grid lines. Those are like in between grid lines. So I could have also counted my rise over my run and seen that my slope is 1 over 3. Now that I have that, they're asking for the x coordinate. They want the x when y equals 12. I can just plug that 12 in for y and solve. So 12 equals 1/3 x plus 2. Solve for x. Subtract 2 from both sides. 10 equals 1/3 x. Multiply both sides by 3, and x equals 30, which means none of these answers are wrong. Right. Need to fix that. So x equals 30. Now, I could also have used a table of values. I could have also used a table of values. So using a table of values, what would that look like? That would look like x, y. So I see that x is 0 when y is 2. Then here I see x is 3 when y is 3. And I could have kept going in that pattern. So if I add 3, 6, x is 6, y is 4, x is 9, y is 5, x is 12, y is 6. And I could have kept going with that pattern, but you very quickly see that that could take a little extra time. And so I don't want to waste time on that. So I'm going to do it this way. But like I said, there have been plenty of times where I've taken a test and I've definitely not done it the most efficient way because I can't think of the most efficient way. And for me to sit there and stare at the problem and try to think of the most efficient way would take me longer than just using this table of values. So if that's the way that you need to solve it, by all means, please do that. I'm just trying to show you multiple ways that you can solve these problems. All right, we're going to look at another function in pattern problem. This is definitely going to be found on a case 6 exam for sure, but could definitely be found on any of the other exams as well, because this falls right in the middle gap of where a lot of those assessments overlap. Which table or tables represent solutions of the following equation? Y equals x plus 7. Y equals x plus 7. So we can think about this two ways. I can plug in my x values, plug in my x values, and I will get a y value. If I put an input in, I'm going to get an output. And if it matches these y values, then I know that that matches. So let's just talk about that process first. So y equals x plus 7. So if I plug in -7 into this equation, -7 plus 7 is 0. So that works. But I'm not just going to test 1. I'm going to test 2 or 3 to make sure that that table has a pattern. If I plug in 7 into this, or 0 into this, 0 plus 7 is 7. If I plug in 7, 7 plus 7 is 14. So I realize that this one works. So I know that it has to include number 1, which means C and D are out because C and D don't include 1. And I'm going to move my picture here so that you can see all the answers. Let's test number 2. So if I'm testing number 2, if I plug in 7 in for the x, 7 plus 7 is 14. That does not match the y value in this table. Those don't match, so this is not a match. Let's test number 3. If I plug in 4 into x, 4 plus 7 is 11. Correct. If I plug in 6 into x, 6 plus 7 is 13. Correct. If I plug in 8 into x, 8 plus 7 is 15, and this is a match. So 1 and 3 are both matches. Excellent job. All right, number 8. If a circle has a radius of 6 centimeters, what is the area of a sector with an angle of 42 degrees? So if we're looking for the area of a sector, we're looking for a partial area of the circle. We're looking for just a part of the circle. So I know that area of a circle equals pi r squared. So let's start with finding the area of my whole circle. So I know pi r squared. I accidentally erased my circle. So I know that the radius goes from the middle out, and that value is 6. If they gave you the diameter, you would have to cut that in half. So if they said a circle has a diameter of 12, then you would take the 12 and divide it by 2, because a diameter goes from end to end and cuts through the center. Keep in mind that this is not a diameter. It goes end to end, but it does not cut through the center, so that is not a diameter. A diameter has to go through the center, which means it's really just 2 radiuses. I have a radius here and a radius here. That's why you divide your diameter by 2. Anyways, moving on. We don't need that information. Area equals pi r squared, which is 36 pi. Now, I am not going to multiply 36 times 3.14. Why? Because my answer choices all have pi in them. So I'm not going to get rid of this pi. I'm going to keep it. Keeping it means that we have a more exact answer. If I do 36 times 3.14, and I do 36 times pi in one of those fancy calculators, I'm going to get 2 different answers because I'm actually rounding off pi at 3.14 rather than using the entire exact measurement of pi. So because they have exact measurements, I want to have exact measurements. Now, that's the area of the entire circle. How do I figure out what part is 42 degrees? Because this is not a percentage. That's the degrees of that sector. Well, if I have a sector with 42 degrees, I need to figure out what percentage of the circle that is. So to figure out that percentage, I need to do part over whole. What is my whole circle going to be? Not the area, the degrees. 360. And what is the part that I'm dealing with? 42. 42 divided by 360 is going to give me the percent of the circle that I'm dealing with. So I'm going to do that in my calculator. My phone died, so I'm going to use my computer calculator instead. Story of my life. Sorry, this is going to be a little bit more cumbersome for me to use my computer. So 42 divided by 360 equals 11.666 repeating. So 11.67%. I'm going to multiply that times 36 pi, or just the 36 really, times 36, and I get 4.2. I'm trying to see if I did anything wrong on this because I don't have the correct answer here, and I feel like I solved this. Radius of 6, area equals pi r squared, so that's definitely 36 pi. Angle of 42, 42 divided by 360. Hey, sometimes we all make mistakes. 42 divided by 360 is 11.67, and I multiply that by 36. And that gives me the area. Okay, so I need to change this question as well. So this is going to be a 4.2 pi. So B is our answer. All right, let's keep going. I'm actually going to skip to problem 11 because this problem is from last week's problem set that we didn't get to yet. And if you want a copy of all of these slides, here is, I'm going to post the link that you can use to access these slides. So if you want to go back and practice again, you can absolutely take this link, download these slides. They are not going to have my notes and chicken scratch all over it. They're going to be blank problems, and just keep in mind that those two problems that we did today did not have a correct answer. I'm going to go back and fix that. So I'm going to post this link so that you guys can download these problems. And then we're going to talk about problem 11. This one is a leftover from last week. So which of the following geometric solids has 7 faces, 10 vertices, and 15 edges? Which of the following geometric solids has 7 faces, 10 vertices, and 15 edges? Here's what we need to know. We are dealing with prisms or pyramids. So let's look at the definition of a prism versus a pyramid. A prism has 2 identical bases and rectangles surrounding that. A pyramid has 1 base and triangles extending up to connect those pieces together. The way we name a prism or a pyramid is with the base. So if it's a triangular prism, it's going to have 2 triangle bases, and then they are going to be connected by rectangles. If it's a hexagonal pyramid, it's going to have a hexagon base and then triangles extending up from that to create that pyramid shape. So if we're looking at a shape that has 7 faces, that means it has a total of 7 sides. Well, a triangular prism is going to have 2 triangle bases plus 3 rectangles. Why? Because a triangle has 3 sides, so there are going to be 3 rectangles surrounding that prism. That's going to equal 5 faces, so A is not correct. A pentagonal prism is going to have 2 bases because it's a prism, plus how many sides does a pentagon have? 5. So that equals the 7 faces we are looking for. But we're not just going to choose that because we found a 7, because there's other characteristics we're looking for. A hexagonal pyramid, 1 base. How many sides does a hexagon have? 6. So I'm going to add 6 to that. That also equals 7. A rectangular pyramid, 1 base plus 4 triangles, because a rectangle has 4 sides. So there's going to be a triangle for every side. So that's going to equal 5. So that's not going to be correct either. So I've already eliminated 2 answer choices. If I'm running out of time, I could just take a guess. Now, it's going to have 10 vertices. Vertices are where those edges are going to connect at a corner. So this is a vertex, 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 vertex. For a pyramid, there's going to be 1 on top and then 1 at each corner of your shape. So a pyramid is going to have 1 more vertex than the number of corners on the shape. A prism is going to have double the amount of vertices because there's going to be vertices for each of the bases. So that said, I already know it's going to be my prism because it's going to be a pentagon, which is 5, which means 5 vertices, and 5 vertices equals 10 vertices. So pentagon is it. A hexagonal pyramid is only going to have 7 vertices because it's going to have the 6 on the bottom and then the 1 on the top. All right. Everybody needs to be able to understand and know how to classify these shapes, because my K through 6 GK people, Praxis Core, you guys are going to have to be able to just identify and talk about them. My middle school and high school people, you're going to have to do surface area, volume, partial volume, all of that. So you're going to need to know the characteristics and then be able to use that information to solve. All right. Which of these, this is also a leftover problem from last week, which of these is the slope-intercept form of the line that passes through points -4, -6, and has an x-intercept of 2? So this is also going to be a problem where I'm going to eliminate answer choices very quickly. I know I'm looking for the slope-intercept form of a line, which means I'm going to get rid of A and C. Why? Because this is point-slope form, and this is point-slope form. So already I'm down to letter B and letter D. Slope-intercept form of the line that passes through this point and has an x-intercept of this point. So I see that both of these leftover answer choices have the same slope. The only difference is the y-intercept. Do not let this trick you into thinking it's automatically D, because in slope-intercept form, this value is your y-intercept, not your x-intercept. So I can either graph it or I can find the slope and solve. I'm going to quickly draw a graph and see if that helps, because finding the slope, putting it in point slope form, and then solving for that is going to take a lot of time. So I'm going to draw a grid and I'm going to graph an x-intercept of 2. I see your question, Gary. Let me finish this problem and I'll answer it. So x-intercept of 2, 1, 2. I'm going to plot a point there. And then it goes through the point -4, -6. -4, 1, 2, 3, 4, -6. 1, 2, 3, 4, 5, 6 is going to be somewhere down here. Already, I can see that it's B, and I'll explain why in a minute. If I connect these points, I notice immediately, even if my graph is not drawn exactly correct, I see that it's going to have a y-intercept that's in the negatives, -2. These two dots on no planet are going to cross up here at y equals +2. So I can see, even if I didn't draw my graph exactly correct, I can quickly see that it's going to cross at -2. Like I said before, could I have taken -4, -6, 2, 0, found the slope using y minus y over x minus x, put that slope into point slope form and solved? I absolutely could have. But I'm also trying to figure out ways that I can save a little pocket of time so that I can use it on the more difficult problems. Gary, I had a question that asked how many diagonals can be drawn on a dodecahedron? Is there an equation to calculate that? You have stumped me. I am going to add that to my problem set for next week because I want to make sure that I answer it, because you're not going to be the only one that has that question, but I want to make sure that I can answer it in its fullest capacity. So I'm actually going to take a picture of that question really quickly, and I'm going to make sure that I answer that next week in our Wednesday math session, so that I can answer it in its entirety. So, is there an equation and how many diagonals? My mom has actually got my son right now in the back. She probably could answer that question because she's a high school math teacher. I'm certified high school, but I definitely have to brush up on some things sometimes because I don't use it every day. Anyways, all that said, I will answer that question next week. That was way more information than you needed. All right. That said, we have time for one more problem, and then we will break and we will meet again next week. Mr. Johnson is doing an activity to introduce his lesson. He shows students a dot card like the one below for a couple seconds, and then asks students how many dots they saw. What skill is Mr. Johnson most likely working on using this activity? So this is for my pre-K through 3, K through 6 people. This is a teaching strategy question, but it's important that you understand the vocabulary behind this. This is one of those problems that right away you should know the vocabulary. This is going to be subitizing. Subitizing is the idea that if you look at a image, you can quickly understand how many dots there are by using some sort of strategy. It's the same reason that when I say, how many dots do you see? You immediately know it's 4, because either you're familiar with a dice or you saw 2 plus 2 is 4. With this kind of subitizing, this would be a very difficult subitizing question for like a kindergarten class. This is going to be done in a kindergarten, pre-K, first grade if the student is on a tiered intervention. But they might say that they see 4 rows of 4 there, and then 2 and 2. They might see groups of 4 here, and then 2 and 2. There's a lot of different ways their brain might visualize it, but visualization is really important at that age, where the idea is not that they're going to sit here and count all the dots, because they're only going to be looking at this card for a couple seconds. So they're not going to be able to go 1, 2, 3, 4. They're not going to have enough time. So it's not counting, because they're only being shown this for a couple of seconds. They're also not working on addition and subtraction because they're being shown one card for a couple of seconds. And so that is the definition of subitizing. All right. That said, thank you all for joining me. Gary, I will make sure I go over that matrix problem and that dodecahedron problem next week. If there's anything else y'all want me to go over next week, drop it in the comments or leave me a message on our Facebook page, and I will be more than happy to add it to my set for next week. Other than that, I will see y'all next week. I'm going to turn it back over to Dr. A. He has a special code for those of you who are still here, and I will see you guys next week. To all of the mothers, have a wonderful Mother's Day on Sunday. I know I'm going to enjoy it. It's my first Mother's Day. So all you mothers, happy Mother's Day, and I will see y'all next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.